So here are some pictures. So we start off with our two associations, A1 and A2, and they give us these two lines, in this case where n is 2, and n1 and n2 are 1. And we make the neural network learn both of these, so the weight vector W0 must be somewhere in the intersection. And in this case, there is only one point. Now, there is something we have forgotten. We have forgotten the origin. There it is. That's 0. And at that place, the brain is dead. It's not producing any signal. The output is always 0. And so now we have decay. What was W0 moves to W1, which is on the line between W0 and 0. So W1 is R times W0. And how far have we moved away from L1? That far, given by the dashed blue line. Then we're going to relearn A2. So that moves us into line L2 by what's meant to be orthogonally along that blue arrow. There's W2. And now let's look at the distances of W1 from L1. So that's how bad we are at knowing about associations in L1 after forgetting. And then this dashed line is the distance of W2 to L1, how bad we are at knowing about things in L1 after relearning L2. And in this picture, you can see that by relearning, we've moved further away from L1. So delta is negative. Okay, this is just a picture. I could have drawn another picture. Well, we can go through and do the mathematics again, and we get some, and we can ask our friend Chebyshev, and we get some results. Under synaptic fading, this new way of forgetting, then, and the usual conditions, then delta tends to be negative because its expected value is negative. And the probability of getting something positive, instead of being nearly 1, is nearly 0 when the system gets big as n tends to infinity. So under fading, free lunch is very unlikely. It doesn't happen very much. So let's have a summary. If the forgetting is by drift, then free lunch is very likely. You're very likely to recover what happened. Under fading, free lunch is very unlikely. It doesn't tend to happen. So the probability of free lunch learning depends on the forgetting. I could say the probability of free lunch learning depends on how you forget. So I could say remembering depends on how you forget. And here we are, back at St Andrews. That's all I know about free lunch learning. But what I can say is I found it very enjoyable, that some simple probability theory can be used for something like psychology. I hope you have enjoyed it too. Thank you.